Hello, everybody. This is Monica Paolini from Senza Fili, and today we're going to talk about power efficiency. Power efficiency is an extremely fascinating topic to me because it really touches all the parts of a wireless network or wireline network, for that matter. And today I have the pleasure to talk to Rob Hughes, who is the head of wireless marketing at Fujitsu Network Communications. And we're going to talk about all the different facets. Well, maybe not all of them, but many of them about power efficiency, how we should think about it, and where is it coming from. And we all know how important power efficiency is, but the question that is often not discussed is how do we get there? And Rob has spent a lot of time thinking about it and working on it, and not just doing the thinking. And so today he's going to share his view on this. So Rob, welcome to our conversation today.
Thank you so much for having me, Monica. I look forward to the discussion.
Excellent. So before we get into it, I know you for a long time, but maybe you can tell all the people listening today who you are and what is that you do at Fujitsu.
Sure. So yeah, I'm the head of wireless marketing, as you mentioned, and so I'm interested in a whole lot of different topics as part of that, whether it's transport solutions, whether it's service management orchestration and the RIC capabilities, systems integration to tie it all together. But over the past few years, the number of Open RAN sites has been growing by factor of 3 to 4 per year. So that's sort of where I'm focusing most of my energy these days. And, as we talk about focusing energy, power efficiency comes into a big part of that. And a lot of people are interested in it. And so I'm spending a fair bit of time thinking and working on how we can improve it.
We're going to talk later about the intersection of Open RAN and power efficiency. But before we get there, let's talk about Fujitsu as a company. Because there is a lot that you do for your customers, but what is it you do in-house?
Well, there's a lot of different things that we're working on in-house. I mean, to be honest, from a personal perspective, I want to do what I can to make the planet a better place for my own kids, and so that makes me proud to work for an employer that's really shares the same vision. One of transforming business to drive positive, lasting change. For the environment, but also our economies and our society. Within the network communications group here in Fujitsu, as I've said, we're focusing on selling Open RAN. So to stay competitive in an open environment, we have to listen and respond to what our customers are looking for. Many operators, particularly those in some of the European countries, are committed to achieving net zero emissions by the 2030 to 2040 timeframe, and so we're largely focused on helping them achieve that. Within Fujitsu Network Communications ourselves, our goal is to try to reduce CO2 emissions by 50%. By 2025, and that's compared to conventional base stations. So there's a variety of ways that we can do that, and we'll talk, I'm sure, a little bit about how to do so over the next few minutes.
Okay. So you're working on Open RAN and power efficiency at the same time, and clearly there is a huge opportunity because you're developing a new RAN at the same time that you're trying to achieve a better energy efficiency. And the two really work very well together. So can you give us a sense of how the two fit together?
Sure. So I think when we look at energy efficiency, it's not one single thing that can improve energy efficiency. There's a variety of different solutions. And so unlike a single vendor solution that looks at an end-to-end solution, they're sort of locked in to what you can get from one vendor. Whereas if you break the network up into different components, you can move at a much faster pace. You can innovate more quickly so that you can take advantage of any improvements that come out in any given area as soon as it becomes available, whether that's in new radios, whether that's in new hardware, software, whether that's in new silicon. all of whatever the newest thing is that's available, you can quickly take advantage of that to help reduce those or get closer to that zero carbon footprint that MNOs are targeting.
Absolutely. And we're going to get into the details of how that works. But can you tell me a little bit about how do we achieve those targets in terms of from a sort of financial point of view?
Sure. Well, I think there's two ways that people can approach that. One is to develop solutions in-house that are going to reduce their carbon footprint, or the simplest but more expensive way is to just buy carbon offsets. But I think you'll see that carbon offsets incur a real tangible cost to the company that CFOs are going to want to avoid. So I think you'll start to see that MNOs have their chief financial officers applying more pressure to the engineering organizations to find solutions that are able to generate carbon savings in-house rather than purchasing carbon offsets. And so there's a variety of technologies that I'm sure we'll discuss today that can help people achieve those goals.
But at the same time, it's interesting because with the offsets that you can buy, you have a sense for how worth it is in actual dollars or whatever the currency is, because you know how much money you're saving compared to that. So that's actually helpful even if you don't use it.
Absolutely. Yeah, just the awareness of applying a financial criteria to your engineering decisions. It's not simply doing everything you can for the environment. It's focusing on what can help and improve your sustainable goals, but in an economical way.
Now, if we look at go back to the Open RAN and say, what is that we can actually do it? Now, why is Open RAN going to promote better efficiency? What is in that compared to a traditional RAN?
Sure. Well, I think with a traditional RAN network, you've got the opportunity to do an end-to-end solution and to try to look for efficiencies there. But then you're kind of stuck with the pace of innovation with that vendor has, and that vendor may have different incentives on developing that innovation. In an Open RAN environment, you've got people that need to constantly compete in order to continue to win business and stay in place. And so that's an incentive to innovate faster. And that can happen at any different section of the network. So it can, like I said, it can be in the radio, it can be in the software, it can be in applications that are looking at end-to-end solutions. Whatever that is, you have, as an MNO, you have the choice of choosing whoever has the best solution. And I think that helps propel the speed of improvements more quickly.
Let's go back to the RAN, because when you talk about power efficiency, the first thing that people think about is the RAN. We're going to go beyond that. However, let's start there because it's still true that most of the power is consumed by the RAN. So how did you go at Fujitsu in terms of addressing that issue?
Well, over the past 25 years, Fujitsu has been building high-performance radios, and we've been continuously improving in that time. Over the past several years, there's been a lot of work done to reduce the size of the radio, and that's been to make it easier to deploy, more flexible to deploy, that reduce your tower lease costs, etc. But now we're applying that same kind of concept of miniaturization to the power amplifier blocks in order to improve energy efficiency. So we've been taking some of the chips that we're developing in-house, and chips, they used to be around that kind of size is sort of typical, and we've been shrinking them more to that kind of size where they're 1/8 the size of the original solution. And that miniaturization allows us to reduce the lead line loss, and that, of course, makes them more efficient. Similarly, by doing a lot of in-house chip development, well, we can optimize our gallium nitride chips for the intended power and frequency and get a little bit more efficient out of that as well. So those are some of the things that we're doing inside the radio. But there's many different things that are driving improvements in energy efficiency.
Do you have a sense of how much an operator can save in terms of power consumption?
Yeah, so like the solutions I mentioned just now, that can generate in the neighborhood of 25% energy efficiency improvements. But often people are thinking about power savings, which they should be doing, but it's not just about power savings. If you reduce the amount of power that you're consuming, that has all kinds of other tangential benefits as well. So you can really cut down on the amount of battery backup that you need, and that drives CapEx savings and all kinds of other environmental improvements as well.
Absolutely. Yeah, and I think that's something that we often sort of forget, because we look at, again, power consumption, which is important. Not to say it's unimportant, but there is much more in terms of, if you have a smaller footprint, you can put more equipment on the same tower. So there's all sorts of other things that maybe less directly contribute to the power efficiency. And so, okay, so that's kind of like the sort of the bread and butter of things. But let's just move forward. And what is beyond that? What about the software, especially with Open RAN, when you start having more centralized RAN, virtualization? How is that playing into, what is the role of software here?
Okay, well, there's a couple of different ones. Let's talk first about the AI and machine learning. I think AI will play a large role in driving efficiency within a disaggregated Open RAN network. You can use AI and ML to anticipate traffic loads and turn off the higher band RUs or small cells that are not necessarily needed at a given point in time when traffic levels are low, and still maintain the same quality of service that you want for your subscriber, the same subscriber experience. And you can use AI and ML to anticipate what that is, and then adjust by completely turning off the transmit power on the radio at times when a given radio may not be needed. So if you've got a lower band available for coverage and you don't need the higher band for capacity offload, you can turn that off. And so I think AI and ML will play a big role in driving those kinds of efficiencies.
Is that based on sort of historical data? So that at a certain time of the day, people use it less, or is it just sort of a near real time and you see things are slowing down and then it's okay, we can switch it off?
Well, there's a lot of solutions out there that are sort of rules based on time of day, but the AI ML puts a different layer on top of that, so that you're looking at things on a cell by cell basis. And you're doing it, you're making decisions relative to what you've seen in the network recently. So if a new condominium complex goes up in the neighborhood and you've suddenly got lots more traffic, the model will adjust on its own without having to be purely rules-based. So that's where the AI is coming in. And if you implement that on an Open RAN RAP, like Fujitsu's is, then that can easily be ported to work on other vendors' RICs. So you can anticipate loads and improve the power in those multi-vendor environments, even on radios outside of the given vendors, like in our case with Fujitsu. So again, it's another example where operators can benefit from whoever innovates the fastest and develops the best of breed software to go with it.
Absolutely, because they're decoupled, so you can mix and match whatever works better at any given time. So again, you're not stuck in this specific time slice. You just, as you move on, you just can get whatever becomes available that it's better. And okay, so another thing, so with Open RAN, you have disaggregation, but you also have increasing levels of virtualization, which you don't need an Open RAN for that, but clearly Open RAN encourages operators to move in that direction. So how is virtualization going to help here?
Sure.
Or is it?
Yeah, I think it absolutely does. According to an Omdia survey that we commissioned earlier this year, 65% of MNOs are expected to deploy virtual RAN in their network this year, and that percentage grows over the coming years. So this gives you the operators the opportunity to drive efficiencies via centralized RAN and pooling. So for people that may not be familiar, centralized RAN is about having many distributed radios all connected at a centralized hub. And when you aggregate many cells into a single DU or decentralized unit, you're able to use your compute resources much more efficiently and need less hardware as a result. So of course that translates to better CapEx, but less hardware also drives less power consumption, etc.
Yeah, but could you say that if you have a distributed type of architecture, you just have more of consumption on site, but maybe it's cheaper there, and then you have less of a transport overhead. So how do you go? Is there, I guess what I'm asking you, is there a solution that works for everybody the same way? And if operators, that's the way you do it to be power efficient?
I don't think it's it's a one size fits all. I mean, you could answer that purely from an energy efficiency perspective, and just say everyone should go centralized RAN. But the reality is that there's some economic benefits associated with using the existing transport facilities that are already going out to the towers. So I think that's why many operators are today predominantly still using distributed RAN. But I think over time, as people start going more into campus environments, as they start going indoors, as they start densifying their networks, and they've already got the coverage out there, that's going to drive more and more people to deploy small cells and to deploy in places where fiber isn't already existing. And if you're deploying in an area that doesn't already have fiber, then you're better off deploying in a centralized RAN environment because of all the benefits that you get with pooling. So I think it's one of those things that we're going to live in a combination of both worlds, and people will increasingly use centralized RAN, but it's going to take a while.
And I guess back to your previous point, you can change through time. So whatever an operator does this year, they might just go for a distributed RAN now and then centralize gradually. Some do not have front haul. I mean, they just don't have it in place. So it needs time. They need time, and that's the beauty of Open RAN, that you can change as you go. You're not committed to.
Yes, absolutely. Well, once you deploy a centralized RAN, then you can start to get a number of benefits from pooling. So you can get the benefits of having extra redundancy, etc. But with pooling, you can take multiple radios and concentrate them onto one DU. But with a virtual RAN, you can also take multiple DUs and concentrate them onto a fewer number of CUs, etc. So we've got a couple of different technologies, whether we call dynamic resource allocation and vRAN autoscale, that enable those kinds of capabilities, so that you're able to constantly be looking at ways of pooling to reduce CapEx and to reduce the power consumption as well.
Yeah, and I guess that's an important point, is how you do the pooling also matters. It's not just you do the pooling, and that sort of brings the question of, if you have pooling, if you have a centralized, virtualized RAN, what is the role of having accelerators? Is that
sure?
How is that going to work in terms of power consumption and efficiency?
Sure. So there's many different accelerators on the market, and they have different pros and cons. In one of the solutions that we've deployed right now, one of the things that we quite like about it is the card that we're using from NVIDIA, for example, has 7 different cores, and using capabilities from Wind River's OCloud platform, we're able to turn off the power to unused cores. So people can deploy now, knowing that they may grow in capacity over time, and they've got the performance and the ability to do that over time. But you don't have to pay for all the power up front. You can only pay for what you need. And similarly for off-peak times when you don't need all of that computing power, you just turn off those cores and save money. But when we look at accelerator cards as a whole, like I said, they have different pros and cons, different advantages. So there might be some deployment scenarios where some make more sense than others, and so it's important to have sort of not just one solution, but a couple of different options.
And that goes back to the fact that, the more choice you have, given that there is no recipe that works for everybody. And especially because it doesn't matter, but because traffic grows, the distribution, the type of traffic, everything grows. So for an operator, it's not a static solution. Hopefully everything grows, and we don't want to tell people you should not doing it. You should not be using your phone because it's you're consuming too much power.
Yeah.
So
yeah.
that sort of changes over time, and also it does change across different deployment scenarios. So for the same operator, in any country, you have rural areas, suburban, urban, and different type of physical environment. And so how does an operator think about that?
Well, I think initially many operators are just focusing on getting coverage out there as soon as possible. So that's why having an accelerator card like the one that we're proposing that has the capacity and has the performance to handle the dense urban environments, but you can also turn the power off, also makes sense. Over time, I think we'll see people start to deploy multiple options. So in the dense urban environments, like you say, you need the really high performance capabilities. And you're going to optimize your power efficiency based on that expectation. When you deploy in a rural site, you might say, I don't need a ton of performance out here. What I need is a more economical solution. And you may have different approach to power efficiency there as well. So I think it's important to have the option to use multiple solutions, multiple accelerator cards, so that you can get the right solution across the network.
Yeah, absolutely. It's just not, you just don't have the same, one solution that works for everybody. And it's more of a question to understand what your requirements are and then choose appropriately.
Exactly.
Now, this is all very interesting and paints a much more nuanced and interesting, but I guess it also points out at the big opportunity that operators have in terms of getting the network that they need. And so let's just talk about a little bit what is that you see moving forward, because as I said, it's not necessarily what you're saving tomorrow, it's a longer term. So from your point of view, what does the long term look in terms of improving power efficiency?
Oh, okay. Well, I think well, I guess one of the things that we've been working with is liquid cooling. So Fujitsu does a lot of work with supercomputing, and we've taken the liquid cooling capabilities from that and applied it to our optical transport portfolio. This is primarily for long haul networks. We're not necessarily getting into RAN yet, but we're getting to the point where we're putting 1.2 terabits per second onto a single wavelength and growing to 1.6, and that's getting really, really dense amounts of traffic, and so that generates a lot of heat, and we're able to get a lot of power efficiency through the use of liquid cooling. Now, right now, like I said, that's only applied to long haul networks. But as we move closer towards 6G, we may see those kinds of capacities starting to come more and more into a metro environment and start being applied here. And then who knows, maybe we can take those same liquid cooling techniques and apply them to other areas of the network to make them more efficient. Again, it comes back to that idea that with Open RAN, we're always looking to innovate, always looking to be the next best solution. And who knows, maybe liquid cooling will be that.
Absolutely, and I guess there's all sorts of ways that you can try. You don't know exactly what's going to work, but it's important that you try, and something will come out of it. So, Rob, thank you so much for sharing your thoughts with us today.
My pleasure, Monica. I thoroughly enjoyed it.
Me too, and I hope you enjoyed it too. And this conversation with Rob is part of a report on power efficiency that you can get from the Senza Fili website. Thank you all for listening and watching us. And Rob, thank you as well.
Thank you.